Today is part C, the final part for week 5's lesson on work. You're going to learn how to calculate the work done in various scenarios. So today is sort of like a quiz on calculating work. And so hopefully you went and watched part A and part B already. You want to make sure you have your notes from the last video. Work is W, it's measured in joules, and a joule is a Newton times a meter, force times distance, and that's how you figure out the work done. Here was one main example, lifting an object out of a well. Here's a bucket. It weighs, the force of gravity, it weighs m times g, mass times little g, 9.8. That's the force. And then you lift it a height. This is how far you lift it out of the well. That's a distance. H is in meters. So this is how you calculate the work of lifting something upwards. Let's review our 4 examples that we ended with last time. In all 4 of these pictures, some of these people are doing work and some of them are not doing work. If you remember, you need to have 2 things to have work. And we're talking about physical work is what you want to think about. Not like doing your homework, but doing actual physical work. So you need 2 things to get that done. First thing you need to have done is force. In other words, you have to actually be trying to move something with a force, pushing on. So this gal's lifting the weights, 125 newtons of force lifting it. This gal's pushing the wall with 100 newtons of force, and this boy's pulling at 45 newtons of force. This man is not putting any force on the skateboard. The skateboard is just coasting forward by itself, so he's not putting any force on this skateboard. The other thing you need is distance. You have to actually move something. To do work, you have to actually get something done, which means moving something. This gal is lifting the weights upwards by about 0.8 meters. This boy is pulling the cart forward by about 3 meters in this example. This skateboard is coasting forward 10 meters, so the skateboard is actually moving. This gal here, even though she's pushing on the wall does not move. No distance. So what we need to do is put these together, force and distance in each example. So let's go through these one by one. Here's the man, right? The force is 0 because he's not even touching the skateboard, even though the skateboard is moving 10. So 0 times 10, force times distance is 0. 0 work done. And that makes sense. He's not doing any work on that skateboard. Basically, the skateboard is rolling forward on its own. It's just coasting forward. He's not doing any work to it. It's just coasting. So no work done by him. All right, this woman, she's pushing with 100 newtons, that's the force, but the wall is not moving, so no distance. 0. 100 times 0 is 0. No work done. And that makes sense. Even though she's giving effort into moving the wall's not actually moving, so she's not doing any work. This boy, he's got force and distance. He's pulling it, 45 newtons of force, and it's moving 3 meters. So he's doing 135 joules of work. So he is doing work to that cart to get it moving. And this woman, same thing. She's actually got force of 125 newtons, and then she's got distance of 0.8 meters. She's moving it, 100 joules of work that she's doing every time she lifts one of those weights. So we can see force, you need force and distance to get work done. So these 2 people are not doing any work because this guy doesn't have a force and this woman doesn't have distance. These 2 are both doing work because they have both. So just keep that in mind for all of our examples today, force and distance. So let's start with our first example. We're going to do 3 of these calculations today in your notebook. Here is Larry and Jerry. They're both trying to move this crate and they're helping each other out. They are going to pull the crate 10 meters. So they're moving it 10 meters. Jerry is pushing with a force of 150 newtons. Larry is pulling with a force of 95 newtons. So here's the entire situation. I could ask you how much work Larry's doing, how much work Jerry's doing, or how much work they're both doing together. But we're going to be asking about Larry for our warm-up. So warm-up 1 in your notebook, find your next blank page. It's probably right after your notes from yesterday. Here's our picture. You remember you don't have to copy the picture. And here's the word problem. Larry is helping Jerry move a big box 10 meters. How much work does Larry do to the box? And here's your information. So our typical guess problem. So you are going to have to write GUESS for our problem solving steps. And so for this word problem, don't forget, copy the blue. Here's our setup. First G, the givens. Look at our word problem. What 2 things are we given? We're given distance and force. What is the distance of our object? The object is the box. The distance is what? 10 meters. The box is being moved 10 meters. What about the force? What are we going to put here for when we calculate the force? Make sure you read the question carefully. What is it asking for? So what force are we going to put in? 95 newtons, because it is asking about how much work Larry is doing, and he's got a force of 95 newtons. What is it solving for? What are we trying to find? We're going to put a question mark here because we're trying to find the work done. Okay, now your equation, in this case, again, it's just going to be work equals force times distance. So go ahead and copy that down. It's the newtons times the meters. Now over here, we're going to use GUE, that's good, and then S, guess. The S is for substitute, okay? So now you're going to substitute and then plug in your calculator and solve for work. So what number goes right here? Just look at your equation. Remember, it's like a recipe. Figure out what number goes right here. It is 95 newtons because it says force, 95 newtons goes there. Okay, what about the other green box right next to it? 10 meters, because it says 10 meters, it says distance, and distance is 10 meters. So you plug 10 meters right in there. And now you just plug this in your calculator, 95 times 10. What do you get for the work? 950 joules. Don't forget the joules. Always put the units in box your answer. The work was 950 joules done by Larry. All right, here's our second example. This guy looks like he's, you guessed it, boom, he's lifting the weights. Right, down, up, down, up, down, up. So we want to find out how much work he does when he lifts the barbell one time. Like each time he lifts the barbell, how much work is he doing? Now, I want you to notice that this is in kilograms. This is not the force. This is the mass of the barbell. So we have to turn that into weight. Weight, calculate. How do you get your weight? Mass times 9.8. So weight is mass times 9.8. So we're going to have to take the 25 kilograms here for the mass and then multiply by 9.8, and that will give us our force of the weight. That's going to go into calculate work. So here we are, warm-up number 2. Copy the blue. All right, warm-up number 2. How much work does this guy do when he lifts, each time he lifts the barbell up? So here's our givens and our unknown. What are you going to put for M? 25 kilograms, that's the mass, 25 kilograms. What are you going to put for little g? I'll give you a hint. You can find this on your yellow paper, or your equation sheet is on the information sheet for the test. It's 9.8 meters per second squared, acceleration of gravity on Earth. And then H is the height. What are you going to put for that? 2 meters. He lifts, that's the distance that the barbell moves, 2 meters. And then we're trying to find work, so we put a question mark right here. GU and then equation, right? The equation this time, and I got this right off the notes, but this time it's going to be M times G, which is the weight, right? That's the weight, and then H is the height. So that's force times distance, but it calculates the force for you, mgh. So what goes right here in the first green box? 25 kilograms, because mass is 25, mass goes first. What goes right here? 9.8, because little g is 9.8. And then finally, what goes right here? It's 2, because the height it lifted was 2. Now you got substitute done, and now you just plug in your equation and solve. What do you get for the work done by the weightlifter? 490. Now the units, you have to remember the units, because we always have to put units in our answer. How do you figure out the units for work? Now, if you don't remember, you can look in your table of contents in the very front page of your notes. It's joules. 490 joules of work is how much he does when he lifts the barbell once. All right, one more example for today. This is Kitty. Kitty is resting on his cat tower. Kitty has a mass of 2.3 kilograms. Kilograms. And Kitty goes up and down this tower quite a bit. So we want to figure out, what if Kitty goes from this step, right, and goes up to this step right here. Okay, so how much work does Kitty do going from here to here? How much work does Kitty do to get herself up that far? Let's talk about the distance. Well, the trick about this is I'm not going to give you this distance because this is actually not on the ground, right? The ground is a little bit lower than that. This first step is 0.3 meters or 30 centimeters above the ground. And this step is 2.5 meters above the ground. So the distance you're going to put in here actually is going to be from here to there, because if Kitty is sitting on this step, Kitty doesn't have to do that work to get up here because Kitty already did the work to get at least that far. So what's the distance from here to there? Well, you got 2.5 meters and 0.3 meters. So you're just going to subtract, right? Find the distance, and that'll give you 2.5 minus 0.3 is 2.2 meters. So basically this is 2.2 meters. Figured out. So Kitty is going to move 2.2 meters. Let's go ahead and plug this whole thing in and solve for the work done when Kitty goes from this step to the top step. Okay, warm up 3, our last warm up for today. How much work does Kitty do when she climbs from the bottom step to the top deck? And so here's information, here's our givens. What are you going to put here for M? 2.3 kilograms. That's the mass of Kitty. What are you going to put for little g? 9.8. That's the acceleration of gravity on Earth. It's on a yellow paper. What are you going to put for h? 2.2. Remember, we already figured it out over here. 2.2 meters. That's how far from this step to the top step is 2.2 meters. That's the actual distance that Kitty's going to be moving. Then you got equation, mgh. Force times distance. What goes here? This first green box. 2.3 is the mass. What goes here? Second green box. 9.8 is the little g. And then finally, there's actually a green box right here. What goes right here? It is 2.2 because that's the height, 2.2 meters. Now we substitute and now we solve. So plug that in your calculator. What do you get for your answer here? Don't forget the units. 49.6 joules. That's 2.3 times 9.8 times 2.2. And there you go. Make sure you copy the blue and finish up warm up 3.